right, this lecture video is going to look at the characteristics of solids, liquids, and gases, and then we're going to do another video that's going to look at the processes involved in going from a solid to a liquid, from a liquid to a gas, and then back again. So we're going to start just a basic reminder way back from week 1. Matter is anything that has mass and takes up space, and it can exist in different forms. Typically, we acknowledge 4 different forms of matter: solids, liquid, gases, and then plasma. Plasma isn't anything that we're going to talk about for the purposes of this course, so we're really going to just look at solids, liquids, and gases. But something to keep in mind about matter is that all particles of matter, so atoms, protons, electrons, all of the things that make up matter are always in motion, even when they don't look like it. So even when you're looking at a solid and it's just sitting on your table, let's say, all of the different molecules that make up that solid is actually moving in some way, shape, or form. The faster the particles move, the more energy that object has. And so we call this energy kinetic energy. So one of the characteristics that we'll look at when we talk about solids, liquids, and gases is how much kinetic energy it has. Solids have a very small amount of kinetic energy. You can't see the movement at all. Gases have a high kinetic energy. You can see lots of movement. So what are some properties of solids? Well, solids are going to have a definite shape and a definite volume. So typically the molecules or the particles that make up solids are going to be packed together pretty closely, and those molecules are in a very fixed position, and that's what gives it its definite shape. They do not move very easily, but they are moving, and so they move by just vibrating. They don't really flow past each other or move past each other, but the individual molecules that make up a solid will just kind of vibrate in place. And that's what helps give the solids its fixed pattern and its definite shape and its definite volume. Liquids are a little bit different because liquids have a definite volume. We can measure a liquid. If I have a gallon of milk, the volume is a gallon, right? The liquid does not have a definite shape. The shape of the milk is going to take the shape of whatever container I pour it in. If it's in the milk jug, it takes the shape of the milk jug. If I pour it in like a lemonade pitcher, it's going to take the shape of the lemonade pitcher. So liquids have definite volume, but they don't have a definite shape. So the particles in a liquid are always in contact with each other, so similar to the particles in a solid. But the attraction between the particles are not as strong as they are in the solid. And this is what's going to allow liquids to flow, is because the particles can actually move and slide past each other because they're not so connected to each other. So liquids and the particles in liquids can actually flow around each other versus just vibration that occurs in a solid. And then gases do not have a definite shape, and they do not have a definite volume. Gas particles are spread out everywhere in the container that they hold, and they will move close together if we compress it. So one of the characteristics of gases is that we can squeeze those molecules together or compress it. We can't really do that with liquids or solids. And because all of these molecules that make up gas particles are floating around everywhere, they have a ton of kinetic energy. They have the most kinetic energy out of all of the solids, the liquids, and the gases. And so in chemistry, we spend a lot of time looking at these different properties of gases because it's such a unique thing. As those gas molecules are moving around, they bump into each other. And as they bump into each other, that will even increase the movement of those molecules even more and cause even more kinetic energy to occur. So when we talk about solids, liquids, and gases, we call this the kinetic molecular theory. And really we focus on how it relates to gases. So what this means is there's 5 parts to it: that gas particles do not attract or repel each other. So unlike solids where the particles have a really tight bond with each other, and liquids where they have a little looser bond, but they're still kind of bound together, gas particles don't have any kind of bond to them. They don't attract each other, they don't repel each other, they're just floating around or moving in the container that they're in. Gas particles are smaller than the space between them, so basically almost all the volume of any gas is just empty space. Space that's just holding these particles that are moving around. Just like solids and liquids, gas particles are always moving. They can flow around each other, they can move, they can bump into each other, they can bump into the walls of the container. They're always moving. There is no kinetic energy that's lost when a gas particle collides. So when two particles bump into each other, neither one of them loses any energy. And then all gases have the same average kinetic energy at a given temperature. So these are kind of the 5 bases of gas molecules and how gas molecules move. When we talk about gases, we will always refer to gases using temperatures in Kelvin. So remember 273 Kelvin. And you can always figure out what the temperature of something is in Kelvin by just taking 273 and then adding the temperature of whatever the Celsius temperature is to that. So what are some other properties of gases? So behaviors of gases can depend on a couple different things. They can depend on temperature. So if you have a higher temperature, you're going to have a higher kinetic energy, which means the particles are moving even faster. So high temperatures or changing the temperature can change the speed or the motion that gas particles move in. Volume is the amount of space an object takes up. So if you have a certain amount of gas particles in a small amount of space, they're going to be moving and bouncing off each other at a faster rate than they would be if you have a large amount of gas particles in a bigger space. And then pressure. Pressure is the amount of force per unit area. So the more pressure that you have on a gas, the more those particles move up, move around, and collide with each other, increasing the amount of kinetic energy. So temperature, volume, and pressure are really important properties of gases because if we change any of these, we're going to change the speed at which the gas particles are moving around, and thus we're changing the amount of kinetic energy that's there. So when we talk about gas pressure, we often refer to that as atmospheric pressure. So gas pressure is caused by the collision of gas particles with each other and with the walls of the container. And as I mentioned, as the number of the collisions increase, pressure will increase, temperature will increase, and then volume will also play a role in the number of collisions as well. You will get more collisions if there are more particles in a particular space, and if temperature increases and if pressure increases, because those two things are going to cause the particles to bump into each other more often. Like I mentioned, when we refer to gas pressure, oftentimes we are relating it to atmospheric pressure. So atmospheric pressure is the pressure caused by the air in our atmosphere, which is all gas, like oxygen gas, nitrogen gas. Atmospheric pressure depends on weather. It depends on the altitude, what your elevation is. And as altitude increases, as you climb a mountain, atmospheric pressure is going to decrease. The air is actually going to start to get thinner. When we talk about standard pressure, we're talking about measuring it at 760 millimeters of mercury. That's the pressure that would be at sea level. And if we converted that, that would equal 1 atmosphere, or another unit that we use to describe atmospheric pressure is the kilopascal, and that would be 1 atmosphere would equal 101.3 kilopascals. Atmospheric pressure is really important because it is going to drive our ability to breathe, to bring air into our lungs. The difference between the pressure in the atmosphere and the difference between the pressure in your lung, your thoracic cavity, where your lungs are, is what's going to pull air in. So those of you who will move on to general A&P and advanced A&P, we'll talk a lot about this when we get to the respiration unit. There are a couple gas laws that we're going to get more into detail in a different video, but just to go over them really quickly, basically these gas laws are going to be able to explain what happens when we change one of the factors like pressure, volume, or temperature. So really there's 4 important gas laws. There's more than that, but there's 4 that we're going to talk about in this class. Boyle's law is going to compare volume and pressure, and it's going to state that volume and pressure will move in opposite directions. So as the volume of a gas increases, pressure will decrease. Go back. Charles' law is going to compare volume and temperature, and it's going to say that it moves in the same direction. So as temperature increases or as volume increases, temperature will also increase. Avogadro's law is going to look at the volume and the number of moles of gas. So as the volume increases, so does the number of moles of a gas. And then the ideal gas law is going to take into account all the factors above, and it's going to put it all into one equation where pressure times volume is going to equal N, which is the number of moles, that would be Avogadro's, times R, which is a constant number that you would be given, times temperature, and temperature in Kelvin. And again, you'll be working on some of these math problems, looking at another lecture video that will go through these. So here's final little checkpoint quick. What state of matter do each of these represent? So this one would represent a solid because the molecules are tightly packed together in a fixed arrangement. This one would represent a liquid because the molecules are a little bit more loosely arranged, and this would represent a gas where the particles are floating all around. So that is a quick description of the different properties of solids, liquids, and gases. And again, we're really going to focus most of our time on gases as you go through the gas laws, but we will also look on the next lecture video about what has to happen for a solid to become a liquid, or a liquid to become a gas, and then vice versa, a gas to become a liquid and a liquid to become a solid.